Hi, everybody. Welcome to Mystery and Reason Lecture 7.1. So we have moved on from chapter 4 of Larry Wright's book, which is called Argument Analysis, to chapter 5, which focuses on a specific type of argument called a diagnostic argument, as you'll see if you do the reading. Um, and we'll get into that concept and a lot of associated concepts in this lecture. So let's start with something we haven't really talked about, and that is the concept of explanation. Now, the word explanation, or the word explain, can mean lots of things in ordinary English. In this class, we're going to be focusing on explaining why something happens or explaining why something is the way it is. Okay? I'm not going to confuse you by giving other things that explanation can mean. Let's focus on this meaning, and you'll get a hang of it. You'll get the hang of it soon. One way to think about this would be to call it the scientific concept of explanation, since sciences typically explain why things happen or why things are the way they are. Of course, explanations of this kind are not the exclusive business of science, but in fact that we give them all the time in ordinary life. So let's look at some examples. Sorry, those weren't all supposed to appear at once. Let me fix that. Okay, so let's give some examples from ordinary life, as well as some professional contexts and science as well. So, for example, I can explain why a crashing sound occurred by finding a broken glass. We did that example some time ago. That would be a very ordinary example of explaining why something occurred, right? How about an auto mechanic? They might explain why my car isn't running by finding a bad spark plug. Okay, so they've explained why something is the way it is. Why is the car not running? A doctor might explain why someone is coughing by showing that they have a virus. They run some sort of test, and that explains why the patient is the way that they are. Or to come back to science, a physicist might explain why an electric current flows at a certain rate by noting the presence of a magnet and using the law of electromagnetic induction. So that would be a full-fledged scientific explanation. Okay. So what do all these things have in common? Well, they are explanations of why something occurs or why something is the way it is. But let's bring in another key concept, which is the idea of cause and effect. So the kind of explanation we're talking about can also be called causal explanation. We explain why something happens by giving its cause. Okay. Let's see how this applies to each of my examples. The broken glass is the cause of the crashing sound. The bad spark plug is the cause of the car's failure to run. The virus is the cause of the coughing, and the presence of the magnet is the cause of the electric current. So in each case, the person who gives the explanation points to the cause of the thing that they're trying to explain, right? So when we ask for a causal explanation, this is really an additional feature here, but we've been using the word why throughout, explaining why something happens, explaining why something is the way it is. So when we ask for a causal explanation of something, we usually ask a why question. So let's do the examples. Why did that crashing sound occur? Answer, the broken glass. Why is the car not running? Answer, the bad spark plug. Why is the patient coughing? Because they have a virus. Why is the electric current flowing? Because there's a magnet, and that we know there's a law of induction. Okay. So as you can see, these sorts of questions are going to be, well, you might remember that we've spent a lot of time talking about implicit questions of arguments. So that's exactly what these kinds of questions are going to be. But we don't really see any arguments right now. We're talking about cause-effect relationships, right? So we're going to have to see how this relates to argument and inference. So let's get to that. So notice that in each of these examples of causal explanation, the first thing to be known is not the cause, but rather its effect. And it's the effect that gives rise to the why question. And the why question is asking for the cause of that effect, right? So let's go to the examples again. The crashing sound is the effect of the glass breaking. And it's the crashing sound that I hear, and I ask, why did that just happen? And then I find the cause, which is the broken, which is the broken glass, right? The car's failure to run is something that I first notice, and I ask, why is it happening? And it is the effect of some cause that the mechanic figures out, the bad spark plug. The coughing is the effect of the virus. The electric current is the effect of the magnet, right? In each case, it's the effect that we encounter first, and then we ask for an explanation of it. We ask a why question, and then somebody figures out the cause. Okay. Now, in each case, someone knows the effect first, asks why it occurred, and then figures out its cause. But this whole idea of figuring out something should remind you of one of the ways that I have described inference. As we know, to figure out the answer to a question involves making an inference. Okay, we've been talking about that for some time now. So let's put this together and say these cases we're talking about are cases in which we infer a cause from its effect. Or you could say we start from the effect and we perform an inference which takes us to the cause. The effect is known directly or more directly, and then by inference, we indirectly come to know the cause of the effect that we started with. Okay, so inferring a cause from its effect is the name of the game here. Okay, but we're going to give some other ways of describing that as well. So the one word description of what we're talking about here is going to be diagnosis. And that's why chapter 5 of Larry's book is called Diagnostic Arguments. So let's understand why that word is appropriate. We will use the word diagnosis to mean any inference that goes from a cause, nope, that goes from an effect to its cause. Or you could say, whoa, yeah, see, I've got a typo here. I'm mixing things up. Hold on. Okay, I fixed it. A diagnosis is going to be any inference from an effect to its cause. Okay, inferring the cause from the effect, inferring from the effect to the cause, however you want to put it. Okay. So let's go to so the word diagnosis, of course, or diagnostic, diagnostics, those words are often used in medical contexts as well as in auto mechanics. So when a doctor or mechanic makes a diagnosis or runs a diagnostic, they are inferring the presence of some underlying condition of the body, of the car, whatever it may be. They're inferring the presence of some condition, usually a bad condition, from the outward symptoms. So here's some other words that we might use, especially in the medical context. The symptoms are the effect, the underlying condition is the cause. But you see the symptoms directly, like the coughing, and you infer the condition, such as the virus, right? So that's what I say here. The symptoms are known directly, and we come to know the condition indirectly. We infer it as a conclusion using the symptoms as support. And at this point, I think it's going to be helpful to bring in this diagram here. Um, and yeah, let me add one more bullet point first. So the underlying condition, such as having a virus or having a bad spark plug, that's the cause that once we know it, once we infer it, we can use it to explain why the symptoms were there in the first place, right? So when we first see the symptoms, but we don't know why they're there. Then somebody infers the cause, somebody who knows what's up, right? And once we've got the cause, then we have an explanation for why the symptoms were there in the first place, right? So look at this diagram. It looks a little bit confusing, but this ties together all the pieces here. So the whole thing can be called diagnosis. And let me first call your attention to the two arrows. The arrow of inference goes this way from top to bottom. The arrow of explanation goes the other way from bottom to top. So that's something you want to get used to. Um, okay. So of course, the what does inference connect? Well, it connects premises or support with conclusion. Always infer from premise to conclusion. In a case of a diagnostic inference or a diagnostic argument or just diagnosis, the premise is an effect and the conclusion is the cause of that effect. Okay, that might feel backwards, but that if it feels backwards, that's probably because you're assuming that inference and explanation need to go in the same direction. Sometimes they do, but in the cases we're focusing on right now, they always go in opposite directions, right? Let's just make sure this makes sense. Let's take the example of the virus, okay? So somebody has a cough. That is going to be their starting point. That's what they know directly. That's their premise. I have a persistent cough. I assume it's the effect of something, but I don't know what it's the effect of. Lots of things could cause a cough, right? So I go to the doctor and they perform an inference by using whatever tests and diagnostic tools they have available. They infer the conclusion, which is you have such and such a virus. And that conclusion is the cause of my coughing. So now we can explain. Now we can follow this arrow and explain why I'm coughing based on the fact that I've got a virus. Okay? So there's a nice little kind of loop here where we start from the top, we infer to the bottom, and then we can explain where we started. We can give a causal explanation, which we didn't have at the beginning. We had to perform the inference to get to this underlying level. Think of the premise and the effect as being on the surface. It's visible. We infer down to the underlying uh, condition, and then we explain the visible symptoms that are at the top level. Okay? So it's a nice little system here. Okay, now, of course, all of this stuff, just like anything we do, can be done better or worse. It can be done well or it can be done poorly. We've been evaluating arguments for some time now by saying how good they are how good the premises are at supporting the conclusion. We've been ranking rival conclusions to say which ones are more plausible, which ones are less plausible. So the same thing applies here. The cause only counts as correctly inferred if we can use it to successfully explain the effects. So, what makes it a good diagnosis, what makes this conclusion a good conclusion at the top of the ranking, say, is if it really explains the effect or the premise that we started with, right? So, for this reason, there's another way to refer to this in the study of reasoning, the logic and critical thinking. Diagnostic reasoning is often called inference to the best explanation. Maybe you've heard that phrase, maybe not. An inference to the best explanation, or in our terms, a diagnosis, is when we infer something that can provide an explanation and uh, that we do that successfully, or we have a justified, our conclusion is justified or well supported or correct or best if it really provides the best explanation of the premise that we started from. Okay? The conclusion is justified by the fact that it provides the best explanation of the premise. And of course, we know that that's going to mean better than any rival conclusion, right? Okay, so we're trying to infer what's the best explanation. When we ask, why is this the way that it is? Why is the car not running? The mechanic says, I think I've inferred the best explanation. It's this spark plug that has some, damage to it or whatever. Okay, they've inferred something that provides the best explanation of the symptoms that I'm experiencing when I'm trying to drive and not able to. Okay. So we've got a few different ways of talking about the same thing. We can call it diagnosis. We can call it inference to the best explanation. We can describe it as inferring from an effect to its cause. Okay. Or inferring an underlying condition from outward symptoms. Good. A few more things we want to say about this. So, first of all, many of the examples of arguments and investigations that we've been studying in chapter 4 have been diagnostic arguments, although we haven't called them that. So we're going to go back to a lot of our examples again. So consider the familiar case of the motel explosion. The implicit question, so we want to bring in implicit questions into the mix, was why did the explosion occur? A why question like this, we will call a diagnostic question. It's a question that asks specifically for an explanation, for a causal explanation. When we ask why is something the way that it is, we want to know what brought it about, what made it like this, what caused it to be like this. Okay? So a diagnostic question requests or asks for an explanation or a cause. Okay, so to answer a why question is to say why a certain event occurred, i.e., to identify its cause, the event being the effect. And this is what the investigators in the motel case are trying to figure out. They're trying to figure out the cause of the explosion, right? When they infer their conclusion that the maintenance worker caused the explosion, they have figured out the cause, and thus they can explain the explosion, which is what everybody wants to know. Why did the explosion occur? Their answer is the maintenance worker caused it. The crucial point here is that in a diagnostic argument, the conclusion is an explanation, or it is describing a cause that we can use to successfully explain the premises or the premise that raises the question. Okay, so the rival conclusions will always be different explanations of some event. Okay, different possible causes of some effect. And when we evaluate the argument by ranking the rivals, we will be making a judgment as to which one is the best explanation. Somebody's trying to do an inference to the best explanation, but we as evaluators come in and say, did you really come up with the best explanation, or is there a better rival conclusion that better explains the event or the effect or the symptoms that you're trying to explain? Okay, let's get to an example. That's a lot of new concepts, but now let's apply them to a very simple example. We just sort of did the motel, but let's do a new one. So, a one sentence passage here. The house shook violently, so there must have been an earthquake. So, I claim that's a diagnosis. That is an inference to the best explanation when somebody says something like that. So, as you can see, this happens all the time in ordinary life, but of course, it also happens in more technical, professional, and scientific contexts as well. But in this case, somebody experiences the house shaking violently and they reach the conclusion that it must have been an earthquake. So hopefully it's not hard for you to schematize an argument like this whenever you have A, comma, so, and then B. A will typically be the premise, B will typically be the conclusion. So let's schematize it. The house shook violently is the premise. There was an earthquake is the conclusion. Oh, we also have that indicator word must. That helps us to see that that's the conclusion, right? Okay. So there's our schema. The implicit question, what's that going to be? Hopefully you can come up with that quickly. Well, it would just be, why did the house just shake? Right? And we would call this a diagnostic question since it's a why question that is asking for an explanation or a cause. Okay, somebody please explain why the house just shook violently. I have no idea what's going on, right? Why did that happen? Oh, somebody tells me it was an earthquake. That makes sense. That explains it, right? Okay, and let's make sure we understand why the argument is diagnostic by looking at our diagram again. So the earthquake is the underlying cause, which explains the house shaking, which is the effect. So the cause-effect relationship is pretty clear. Obviously, the earthquake is what causes the house to shake, not the other way around. Everybody knows that, right? And then let's look at the inference side of this. The house shaking is the first thing that the person knows. That's what they know directly. That's their premise, the starting point of their inference. And then they infer the earthquake as the conclusion. And again, the conclusion there was an earthquake provides an explanation of the premise, right? Okay, so we've inferred to the best explanation here. Let's just say a few more things about this. Let's talk about some rival conclusions. So there's the house. So some serious rivals here. See if you can come up with some. What are some other reasons why the house could have shaken significantly enough, for somebody to be wondering about it, right? Well, how about a heavy truck drove by? I don't know. Depends where you live, depends on the, quality of the road, maybe how close you are to the road, how, how the house is built and so on, right? So maybe it was a heavy truck that drove by. I've experienced, I don't know if the house would shake violently, but, a little bit. Okay. Maybe it was an explosion nearby. Maybe, I don't know, I live close to, um, a power plant and some huge transformer blew, or I don't know, right? Or maybe it was a subwoofer turned all the way up, right? So my son in his bedroom suddenly turned on some music and the volume was way up, and he's got some new, speaker that plays extremely low bass notes, and that's what it was. Okay. All right, well, let's try to rank these. What would you say? I mean, there's very little information to go on. All we know is that there's some shaking involved. So and all of these are, responsive to these are all possible explanations of the shaking. That's the first thing I want to say is that these are different ways of explaining why the house was shaking. So let's try to rank them by determining which one best explains the shaking of the house. And this is despite our very limited information. So just based on common sense, common knowledge, what do you think? Well, this is what I came up with. I said the author's conclusion sounds pretty good. I put it at the top, so this would be a sound argument according to me. I put the heavy truck second just because I don't know. Trucks are, pretty common. More certainly more common than explosions. And I don't know, the subwoofer probably like it wouldn't be able to shake the house that much unless you had like a serious amplifier. So I decided, look, it's probably going to be the earthquake, maybe the truck. And then I put a gap and I said, okay, maybe it's a subwoofer and an explosion. Well, that's a pretty infrequent occurrence. So I put that at the bottom. Now, of course, this is um, based on very limited information, so we would want to do an investigation if we really want to solidify our ranking and try to have a strong argument, not just a sound argument. So, for instance, if this took place somewhere that rarely gets earthquakes, that would be pretty relevant information. We might want to know, where is this house? If it was somewhere that is nowhere near like a fault line and they never get earthquakes, then C1 would certainly be lowered in the ranking, if not removed entirely. Maybe it wouldn't even be a serious rival if it's a place that never gets earthquakes, right? So we'll talk about that, I think, next time, but I think this is a good enough introduction to our new topic, and so I will leave it at that. All right, I'll see you next time.